So chapter 4 picks up from chapter 3, and that chapter 3 we multiplied polynomials. In chapter 4 we're going to do the reverse of multiplying polynomials and break them up into their factors. So we've talked about factoring at the beginning of this course in the review chapter, and factoring was the reverse of multiplying. So we could have 6 as our product, and we could factor that out into 2 and 3. And so this is factoring. And this way, so 2 times 3 equals 6, is multiplying. And so what we've done is chapter 3, we learned how to multiply, not the numbers, but the polynomials. And chapter 4, we're going to learn how to factor them, how to break them down into their components. And so we're going to start off with this one. We're going to take it slow. So just 4.1 in the first day. And then 4.2 and 4.3 are going to be taught as a bit of a package, but separate days. 4.4 and 4.5 are one day. And then these ones, we come back to word problems at the end. So we've got 2 weeks to work through this material. We've got 6 classes devoted to our chapter 4, because chapter 4, if there's one skill that you could move on to Math 50 with, it is factoring. And so I want to make sure that you've got a solid foundation in your factoring skills. So I did say 4.1, introduction to factoring. Factoring is the reverse of multiplying. So factors are multiplied to get a product. Sometimes putting the mathy words in there can be grounding. And so these are some examples. I already did an example with numbers, like an arithmetic example, but down here would be an algebra example. So in chapter 3, if you were given something that looked like this, you would take the 3 and distribute it to each of the things in the brackets. You would multiply the monomial by the binomial and get this as your product. Well, so this was chapter 3. In chapter 4, we're going to start with this and learn how to break it down into its factors. You can see that this is the reverse. And so this is chapter 4, breaking one polynomial up into the two things that multiply together to get to it. The thing with the chapter 3 and the chapter 4 is that you're going to learn how to do these in forward and reverse. And sometimes you can get locked into this horrible circle in algebra where you go forward and you go back and you go forward and you go back. And so going slow in this chapter 4 and having a strong foundation on it will hopefully serve you as you move forward in math. So this is the textbook pattern. Not a real concrete example, but a pattern that illustrates that you could multiply. And again, that's chapter 3, that distributive property. That's the pattern that we can see here. Or what we're going to learn in chapter 4, this factoring and breaking a polynomial apart into the factors that would get you that polynomial. And so the first skill that we're going to learn in 4.1 is greatest common factor. And so we're going to talk about greatest common factor. And we talked about greatest common factor in terms of numbers in arithmetic in our chapter 0. And we did learn a chart system for them. Most of the numbers that we're going to be dealing with are small enough that you can have, even just with a multiplication table, you can easily, intuitively derive the greatest common factor. If not, that chart that we looked at in chapter 0 is your strategy for when, the facts fail you. So either way, either strategy to get to the greatest common factor. So we're going to take a look at these ones. I'm going to come back to the explanation on the greatest common factor. We're going to start out with just the numbers. So the greatest common factor between 9 and 12 would be the biggest number that would divide evenly into each of them. Most of you will know that number intuitively, and that's a 3, because we have a 3 times a 3 would equal a 9, and a 3 times a 4 would equal a 12. And so 3 is the greatest common factor. I've written it like this just to show you that it is kind of like that math number or that arithmetic example up the top. If you don't want to show your work, that's absolutely fine. If you're like, I can get to the answer without doing all that work, that's fine. We're not going to see that work as we move forward in these. So B, another good example, probably one you don't really want to show your work. The biggest number that would divide into all of these evenly would be 5. And again, you could show your work with this. It'd be 5 times 2 and 5 times 5 and 5 times 30, right? And either in a chart or getting to the answer intuitively, 5 would be the biggest number that would divide into each of them evenly. For C, if I take a look at those three numbers, and hopefully we're all feeling pretty good about the size of these numbers, 9 is the biggest number that would divide into all of those evenly. So we're not doing just math with numbers anymore. We're doing math with numbers and letters. And so when I take a look at the biggest factor, the biggest thing that would divide into each of these evenly, like I've been doing with this exponential notation, sometimes it's easy to kind of write it out for what it means. So x to the fourth would be 4x's, and x to the 7 would be 7x's. And so like I showed at the top here, I could take 4x's out of this and 4x's out of that. So my greatest common factor here would be x to the fourth. If I divided x to the fourth out of this, I'd be left with a 1. If I divided x to the fourth out of this, I'd be left with 3x. And so, you know, if you wanted to show it that way, you could do x to the fourth and 1, and x to the fourth and x cubed. It says at the top here, the greatest common factor is the product of the largest common factor, the coefficients. So that's what we're doing with the numbers through this part, and any variable that appears in all of the terms. And we're going to use the smallest exponent on that variable. And so if we take a look at that explanation and how it applies to this example, I took x to the fourth as my greatest common factor. And so whether you want to expand these ones or just say, all right, I've got these two a's, and the smallest one that I see, the smallest exponent that I see is a to the 5. I could have an a to the 5 pulled out of that one and a 1 as my factors, and I could have an a to the 5 and an a to the 4 out of that. If I wanted to show the factors that I was thinking that made me say that a to the 5 is the greatest common factor. H, if I take a look at that one, I have coefficients, and 1 would be the greatest common factor between 1 and 2, but I do have an x, and x common to both of these. The smallest exponent that I can see is that imaginary 1 up there, and so x is the greatest common factor between those two. Rolling it all together, if I take a look at these two down here, and honestly in these ones, if you're checking my key, I don't show all my work. I usually just put the answer, but I'm trying to talk it through and make this stick in your head somehow. So I take a look at the coefficients first, and I think, what is the biggest number that would divide into both of those evenly? So that would be a 6. And then I see that I have a's in both of my terms. Well, I take the smallest number that I see as an exponent on the a. So my greatest common factor would be 6a squared. The next one over here, identifying the greatest common factor between the 10 and the 35. Numerically, a 5 is going to be the biggest number that would divide into both of those evenly. And then with this variable business, I see that they both have x, and I would go x to the fourth because that's the smallest one that I see. Maybe one more example here, and just off the top of my head, what about 3ab squared and 6 a squared b? So this time I threw in more than one variable just to make things a little bit harder. If I were to identify the greatest common factor between these two coefficients, so numerically the biggest number that would divide into both of those numbers evenly would be a 3. And then I go through looking at the variables, and I pick any variables that are common to both terms and the smallest exponent on those variables that I see. So I've got an a here and an a squared here. So that would give me an a to the 1, or a alone, as a common factor to both. And I've got a b squared here and a b here. So a b would also be part of my greatest common factor. This first little bit is just about identifying the greatest common factor. It's not actually about factoring. It's just about finding that greatest common factor. We're going to keep using this as a skill because it is a way of factoring things. So the first step in greatest common factoring is to find the greatest common factor for all the terms. So what we were just practicing. Then we're going to use that greatest common factor to factor each term. And what I mean by factor each term is to divide each term by that greatest common factor. So you're going to find the greatest common factor. You're going to write it down. Then you're going to write or put down brackets. And you're going to fill those brackets up with what's left over when you divide each term by the GCF. So those are the way that I say it. This was from your textbook. So let's try that on this first example, A. So A says we've got these two terms. So we need to find the greatest common factor. So I take a look at each term and I determine the biggest number that would go into each of those coefficients evenly, and that would be a 4. And when I look at the letters of each of these terms, there's x squared here, but there's no x's here. So my greatest common factor has no variable as part of it. So I found the greatest common factor for all terms. I've written it down. I'm going to put down brackets. And I'm going to fill those brackets up with what's left over when I divide each term by that greatest common factor. So this first term gets divided by 4, and this next term gets divided by 4. And so filling those brackets up, this first term, it's dividing a monomial by a monomial, would give me a 2x squared. The 8 divided by 4 is 2, and the x squared is just left on the top. The second term, when I divide the second term by 4, I get a 3. And this last little bit here, this check is different. So this is the going forward and the going back. So this is chapter 4. If I wanted to check it and do distributive property, that would be chapter 3. And so checking it, I'd get an 8x squared and a plus 12. Now, this has gone, as you can see, right back to the beginning. And so checking it should get you back to the beginning. And checking it is what we learned in chapter 3. And so this is what I was talking about when I said you could go round and round in circles. Let's try all of these, especially with these rules that I've written out as I say them. Okay, so the next one, we've got C here, just because it's at the top. I need to identify the greatest common factor. The biggest number that divide into each of these terms would be a 6. And the variable component, I've got an x in both my terms, and so I just write down 1x. This one has 2 x's, but this one only has 1. So my greatest common factor is 6x. I wrote down my greatest common factor. I'm going to put down some brackets, and I'm going to fill those brackets up with what's left over when I divide each of the terms by that greatest common factor. So the first term, 6x squared divided by 6x, the 6's would go away, and I'd be left with 1x. X2 minus 1 would be just x to the 1 if you thought exponent rules, or they just wipe each other out if you think of it that way. And then I'd have minus 24 divided by 6 would be minus 4, and the x divided by x is 1, and so I'm done. And again with this one, this would be your answer. This would be that polynomial factored, but I could check it. Again, I'm going to switch colors because this isn't really chapter 4. Chapter 3 would have you check it this way. So we should be able to reverse this back to the original question and go round and round in circles. And it does, whoops, sorry, I forgot the X. It does go back to the original question. And so that's what this last part here is saying, check using the distributive property. You should be able to reverse engineer these back to the original question. Okay, so let's move on with these ones. I'm going to leave those words up. Hopefully I'm going to scroll just a little bit, see if I can fit a few more on. Oh, maybe I can't. You'll probably have them on your page. So working through these ones, I'm going to talk them out. I identify my greatest common factor. So for B, it's going to be a 6a squared as my greatest common factor. I've identified my greatest common factor. I'm going to put down some brackets. I'm going to fill those brackets up with what's left over when I divide my greatest common factor out of each of my terms. And so I like showing my work like this because it gives me a chance to catch little exponent errors or what have you. So 6 divided by 6 would be 1, or I'm just going to leave it invisible. And a to the 4th divided by a squared would leave me with an a squared. That's 4 minus 2 is 2. The second term, the negative 18a squared divided by 6a squared would leave me with a negative 3. And again, I could check on this one and reverse it back to the original question. Maybe I'll do that one more time. This is kind of like me verifying my work. You know I don't really love doing it, but this would give me a 6a to the 4th and a negative 18a squared. And again, that's not my answer. That's me just checking my answer. This is my factored polynomial. So D, to factor this polynomial, I always look at greatest common factor. So greatest common factor first would see that I have a 5 as a common factor to these two. Oops, I didn't leave myself enough room. So I've got a 5 as my greatest common factor coefficient, and then I've got an a squared. So I've identified my greatest common factor. I'm going to throw down my brackets, and I'm going to fill those brackets up by what's left over when I divide that common factor out of each of my terms. Oops, copy it correctly. And so D would have me left over with a 2a as my first term and a minus 3 as my second term. And again, you could practice and distribute your greatest common factor to your binomial and make sure that you end up back at your original question. E, when I take a look at this one, I'm going to do this one just a little funky because I know where we're going. Anytime that I see a negative out the front here, I'm going to use that as my sign. In the notes it says take the lead of the leading term. Oh, that doesn't say leading term sign. I was looking away and writing. From the first terms sign. So that means because I've got a negative out the front here, I'm going to have a negative greatest common factor. You wouldn't be wrong had you worked ahead and not done it this way, but I'm going to say my greatest common factor for these two would be a negative 3 and a y. So the first step is to identify the greatest common factor. I'll do this one if you didn't follow this, if you had worked ahead. And now I'm going to put down my brackets. I'm going to fill those brackets up by what's left behind when I divide that greatest common factor out of each of my terms. And so that would leave me with a 6x for my first term in my brackets and a minus 7y as my second term. And so I'm saying that this is my answer. Now, had you not followed my lead on this one or taken the lead from the first term sign, which is something we're going to be doing throughout this and it will serve useful, your answer could have also said 3y negative 6x plus 7y. And that would be absolutely right. Both of those answers are correct. But like I said, because I know where we're going with this one, I've done it with this little caveat, this star in mind. So moving through the last ones here, I've got trinomial in F, and I've got a common factor of just 5 for that one. I put down my brackets and I'm going to follow my own advice. I'm going to divide each of my terms by 5, and that's what I use to fill up my brackets here. So the first term would leave me with an x squared. The second term would leave me with a negative 2x, and the third term would be a plus 3. The last two on the page would give me a 4a squared as my greatest common factor, and factoring that out, I put down the brackets and I'm going to fill those brackets up by what's left behind when I divide that common factor out of each of the terms. So many words. Okay, so the first term would leave me with an a squared. The second term would leave me with a 3a when I do that division. And the last term would leave me with a negative 5. And again, all of these can be reversed back to the original question. So if I've got them in my factored form, I could always reverse them back to the question that was given. Another one here, I've got my greatest common factor. When I take a look across the numbers here, would be 3 would be common to each of those. And the x's, I can see that I've got x's in all, and x squared would be my smallest exponent. So that's going to be my greatest common factor. I put down my brackets. I'm going to divide each of my terms by that greatest common factor and use those to fill my brackets up. So my first term would leave me with a 2. The next term would be a negative 5x. And the last term would leave me with a positive 9x squared. So I have factored that polynomial with the greatest common factor. A few more there for you to try. They get more and more complicated. I'll put my work up. If you're all done those, I'm going to put one more scribbled into the page here because we haven't dealt with our pesky zeros and ones at this point. So keep going on those. Here's one more if you're getting close to finished. And we can talk through all of these in class. Here's our last example. And that seems like a good spot to stop this video.